Okay, so 3.4, the end of chapter 3, exponential and log equations. We have 36 raised to the power of x plus 1 is equal to 6 raised to the power of x plus 6. So we have a base 36 and a base 6. We can rewrite these. So my note for this one is that they must have the same base. The same base to set exponents equal to each other. All right, so you always want to look at the smaller base, in this case the 6, and you want the larger one to match the 6. You want to take the bigger number and turn it into a base 6. 36 is the same as saying 6 squared. So instead of 36, we want to match a base 6. 6 squared is the same thing as 36. So we just turn it into 6 squared. And then it's still raised to the power of x plus 1 equals 6 to the x plus 6. And now that we have the same base, we can take the exponents, including the new 2 that we just wrote. We need to include that. And set the exponents equal to each other. We're basically just dropping the bases at this point. Not technically, but for what we're trying to do, we're not worried about the bases. Once we get them to be the same, we're just going to take the exponents and set them equal to each other. So on the left, we have 2 and then parentheses x plus 1 equals, on the right is just x plus 6. And now we have a simple linear equation to solve where we distribute the 2. So 2x plus 2 equals x plus 6. And we want to subtract the smaller one, so the x minus x. And I'm going to go ahead and at the same time take care of that 2 because I want all the x's to the left, and anything without an x I'm going to move it to the right. It's positive 2, so I'm going to subtract 2. So then I end up with 2x minus x is x equals 6 minus 2 is 4. So x equals 4. All right, the next situation that you will encounter is if you have 1/2 raised to the c, or if you prefer an x, you can put an x there, it doesn't matter, equals 64 to the 1/2 power. All right, so this time we have a different situation, and really we kind of have two things happening at the same time. It doesn't really matter which order you deal with them. I want to deal with the 1/2 first. My exponential base is a fraction. I don't like it as a fraction. So I can use negative exponents to get rid of the fraction. So that's my note on this one. Is in this case, I can use negative exponents. For fraction base or bases. Since the base of the exponential is a fraction, 1/2 raised to the c, I can use negative exponents. So if I have 1/2 to the c, that 2 is to the power of 1, right? If there's not an exponent there, it's because it's to the first power. It's 2 to the first power. Well, if I want to move that 2 to the numerator, that means it's 2 to the negative 1 power. and then it's still raised to the c power. We've worked with negative exponents in the past, but normally it would be, I gave it to you like this, and I told you we don't want negative exponents, so to get rid of the negative exponent, you move it to the denominator. Well, we're kind of doing the opposite. Now we don't want the fraction, we'd rather have a negative exponent. So I have 2 to the negative 1 to the c, which is 2 to the negative c. So I can take this and put it back in here. Instead of that, I can write it as 2 to the negative c equals 64 to the 1/2 power. And what about the 1/2 power? What does it mean whenever you're told something is to the 1/2 power? Remember rational exponent, radical form and rational form. The root is on the bottom because that's where roots are, on the bottom. So 1/2 power is a 2 root or a square root. So this is the same thing as square root of 64. 64 to the 1/2 is the same as square root of 64. I know that the square root of 64 is 8. So I could use 8 instead of 64 to the 1/2 power. So this could be 2 to the negative c equals 8. That looks a lot nicer than what I started with, but it means the same thing. And then from there, I could go back to my rule from the first example, is if they have the same base, I can set the exponents equal to each other. So if I can turn this base 8 into a base 2, then their exponents would be equal. So 2 times 2 times 2 is 8. So I can write that 2 to the negative c equals 2 to the 3rd. And then take the exponents. You can drop the base and say that negative c equals 3. But I'm not solving for negative c, I want a positive c. So c equals negative 3. And there's my answer. All right, so now I'm switching over to logs. I have the natural log of x equals 6. What is the value of x? So if I have a log and my variable x is in the argument of the log, I need to rewrite it as an exponential so I can figure out what the value of x is. So I want to rewrite in exponential form to solve. All right, so I have the natural log of x. If I have a natural log, that means the base of the log is e. It's just an understood, it's not written there, but I feel like whenever you're rewriting it, it helps to see it. So I'm going to write in that it's a base e so that I see the e. I do the same thing with the common log because the common log is a base 10, but it's not written or printed, it's just understood. But whenever you're switching forms, it's useful to see it. So if I want to turn this into an exponential from a log, I have log base e, and my exponential form is going to have the same base. So the base of the log is also the base of the exponent. In log form, the x is with the e. So when I switch to exponential form, the other value gets its turn with e. So for log, x is with e. So for exponential, the 6 is going to be with the e. So it's 6's turn to be with e, and the x goes by itself. So e to the 6 equals x. And that is the exact answer. You don't have to do anything else. X is by itself. This is the exact answer. Now we can approximate x to find out that x is approximately 403.428 by using a calculator with the log function. And you'd have to make sure you're using the correct e. So the ln button is right there next to 4. And see how it says e to the x above ln? So you'd press second ln, and then it gives you e, a lowercase e, and then I would type in 6, and it gives me my decimal. And that's the approximate. So if the instructions say give the exact value, you would give this form. If the instructions said give an approximate, then you would give this form. All right, D. We have 6 plus 2 times log of 5x equals 18. So example D is not that different from example C. But it's worth noting, which is why we're doing this problem, that before you can rewrite the log into an exponential, you have to isolate it. So you have to isolate the log, then rewrite as exponential. Also, whenever I have something like this, and I know I'm going to be moving things around, the argument of the log is not always in parentheses. In the calculator, the argument of the log is always in parentheses. But whenever I'm working with them, I like to put it in parentheses so I don't accidentally mix things together that should not be mixed together. So if you separate it with parentheses, you're less likely to make a mistake. Okay, so I have 6 plus 2 times the log. So I need to deal with the 6. That's a positive 6, so I'm going to subtract 6. All right, so now I have 2 times log of 5x equals 12. So I have 2 times the log. If I'm trying to get the log by itself, I need to divide by 2. Because log of 5x, that's one thing. So it's 2 times that thing. You're not going to have the word log without a number attached to it. All right, so now I have log of 5x equals 6. So at this point, I can rewrite it as exponential form. And when I do that, I like to fill in the base if it's not there. This is the common log, so it's a base 10. So I want to rewrite it as an exponential. So 10 is the base of the log, so 10 is also going to be the base of the exponent. As a log, the 5x is with 10. So when I go to exponential, it's 6's turn to be with 10. So 10 to the 6 equals 5x. But x is not by itself yet. We still are trying to get x by itself. So it's 5 times x. So that means I need to divide by 5. So I have 10 to the 6th divided by 5 equals x. So x equals 200,000. So when you have 10 to a power, that tells me I have a 1 with 6 zeros behind it. But if I have 10 divided by 5, 10 divided by 5 is 2. So it's going to be 2 with 5 zeros behind it. If that's confusing, then don't worry about it. This is not what I'm trying to see if you know how to do. It's all of this that we're testing. So I'm not going to spend a lot of time explaining that part right there. Okay, stop.